All right, so let's look at an example. Example 5. My revenue model is defined by 9 times the number of units that I make. My cost model is defined by x cubed minus 6x squared plus 15x. And we will define x in thousands of units. Typical for business to define our variables in terms of thousands, hundreds of thousands, millions. So to maximize profit, we need r prime of x, the derivative rate of change. Well, let's just refer to it as the marginal revenue. Well, we know that's 9. The marginal cost is 3x squared minus 12x plus 15. And we want those to be equal. So 3x squared minus 12x plus 15 equals 9. Simplifying that, we can set it equal to 0. 3x squared minus 12x plus 6 equals 0. And again, I'm just going to use my quadratic formula. I'm going to plug it into a quadratic formula program. I get that I have a critical point at x is approximately 3.414 units, or 3,414 units, and I have a critical point at approximately 0.586 units, 586 units. Don't know where that came from, but there we go, 586 units. So the question is which is a maximum and which is a minimum? Do we have a maximum and a minimum? We must have something going on there. So let's find out. Marginal profit defined as marginal revenue minus marginal cost. So we've got 9 minus 3x squared minus 12x plus 15. Which is negative 3x squared plus 12x minus 6. The second derivative, and by the way, this is sort of important because when we look down here, we had a positive quadratic, and it might have been easier to say, well, let's just take the derivative of the positive. But that positive quadratic is backwards when we're talking about the marginal profit. So we need to make sure that we actually go back and rewrite the marginal profit, because that changes the derivative to negative 6x plus 12. And what I notice then is that the second derivative of 3.414 is going to be less than 0, making that a local maximum. And that the second derivative of profit evaluated at 0.586 is going to be greater than 0, making it a local minimum. And again, you don't actually have to do this calculation. I looked at this and I said, well, 6 times 3 is 18. Negative 18 plus 12 got to be a negative number. 6 times a half is 3. Negative 3 plus 12 has got to be a positive number. Save yourself time when you're doing these problems, because we're not interested in the value. We're interested in the sign of the second derivative. So, interpretation. To maximize profit. Make 3,414 units. Why don't you do exercise 22 out of the book?